Alright, now we got 5, 7 inequalities in 2 triangles. Not 1, not 3, but 2 triangles. Alright. It's weird that it's 5, 7 though. It's 2 triangles. Yeah. Maybe not. Alright, the hinge theorem. Okay? I'm going to read you the fancy definition and try to explain it to you guys in some ways that make sense. Okay? If 2 sides of one triangle are congruent to 2 sides of another triangle, and the included angles are not congruent. These angles are not congruent. Then the longer third side is opposite the larger included angle. So what they're saying is, hey, this angle is bigger. Okay? The sides are the same. So this side BC is going to be larger than YZ. And the best example that I saw was with pictures, okay? The distance between these scissors, if you guys can see this, okay, I don't know what it looks like on your end, okay? These blades are the same no matter what, okay? So this here and this here are the same, okay? The bigger I open this, the farther apart those get. This segment here is longer, so this is a very short segment, very large segment, okay? That's all they're saying with that hinge theorem. Okay, hence the hinge there. Okay, moving on. We already got there. Okay, using the hinge theorem. Okay, multiple choice. Multiple choice. Which of the following must be true? Well, if we're looking at this. We see, okay, this is 90. This is 70. These sides are the same, which means larger angle, opposite that is going to be the longer side. So SK will be larger than OU. Okay? So which one of those matches that? Not OU. Sorry guys. The triangle's been shifted on me. Okay? YU, not OU. YU. YU is the one that's opposite that included angle, that hinge. Okay? So SK larger than YU, it should be B. Okay, here's another one. Chance for me to redeem myself. Better not erase that whiteboard with the scissors, it's going to really mess that up. Alright. Alright, so 4 and 7. 4 and 7, side lengths are the same. Where's our hinge point? For us here, it's M here. Over here, it's P. Which angle's larger? Okay, 125, larger than 78. So this side, LN, is going to be larger than, opposite, QO. Remember, you guys could write the opposite of this also, which is that QU less than LN. That means the same thing if you're comparing answers with your neighbor or the back of the book. Alright, problem 2. I did not like this problem when I went over this myself. Okay. So the diagram below shows the position of a swing at 2 different times. As the speed of the swing ride increases, the angle between chain A, or the chain, which is this dotted line, excuse me, I think that is what they're talking about. Nope, this is the chain right here. Boom, boom, boom. Okay, and AB increases. Okay, is the rider farther from point A at time 1 or time 2? So they're saying, hey, this angle 1, they're saying, hey, angle 1 is less than angle 2. So when are we farther? At time 2, right? Angle 1 larger than angle 2. So time 2, based on the hinge theorem. Alright, moving on, right? AC here in time 2 is going to be larger than this AC because of the angles, which is the hinge theorem. Alright, the converse of the hinge theorem. right? And all this is stating, I don't know what it says up there. Figured you guys can read that yourself. Pause it if you want. Okay, I'm gonna try and explain to you guys how I think about it. Alright? The converse meaning the opposite of that. So, if these are the same, right? And I know that this side is bigger than this side, I know this angle is bigger than this angle. That's all that's saying, right? Angle A is bigger than angle X, because the sides are longer. Alright, so using the converse of the hinge theorem, what is the range of possible values? This is way more complicated than the one we did with the hinge theorem. Okay, we could very well ask us, you know, which angle's bigger? We know which angle's bigger, right? 60 is bigger than this angle right here, bigger than this one. You might be thinking, Mr. Shell, how do I know the hinge theorem works here? Side, side, common side, right? So these are the two angles we're talking about, here and here, okay? So what are the values for x? This right here needs to be less than 60. Okay, so 5x minus 20 is less than 60. That's not all though, folks. It can't just be less than 60. It also has to what? Be larger than 0, because you can't have a negative angle. So, let's solve this. Add 20, add 20. So 20 less than 5x less than 40, divide by 5. X is going to be between 4 and 8. I think those are our options there. Okay, let's keep moving. What is the range of possible values for x? I'm going to figure the right. You guys should be trying to do this one on your own. You just got to pause it. Right? This is 7, 9. We know that angle K is less than angle N. I also know that 3x plus 18 less than 90, but greater than 0. So I'm going to leave that up there. Solve away. We're going to subtract the 18 from all three sides. You guys should have learned about this. At least in Algebra 2, I remember covering it multiple times, and I believe we cover it in Algebra, actually I know we cover it in Algebra 1. So you guys should know how to do this. Okay, this is negative 18 less than x less than 72. This is 3x. Divide by 3. X is less than negative 6, excuse me. Negative 6 less than x less than 24. Can x be negative 6? So I can't have negative angles, Mr. Shell. Well, as long as x is bigger than negative 6, this angle won't equal that. So that's why this is allowed to be negative 6. The angle is not allowed to be negative 6, you guys, but x can be. That's what the 0 here is saying. The angle, the whole total value of that angle, is greater than 0. And that's the end, guys. Okay. Hey, if you found this video helpful, click the like and subscribe button at the bottom. Thanks.